Hello everyone, and welcome to my fourth attempt to record the video of the day for today for our LeetCode challenge for the 2nd of July. So yeah, it's a funny story, but yeah, it's actually my fourth attempt to record this video because in my first attempt I didn't turn my microphone on. In my second attempt, the text was very blurry, and during my third attempt, my internet broke down. So you know what they say, 4 times the charm. So let's hope that this attempt will be more successful. And today we're going to discuss a task called maximum number of achievable transfer requests. And it's classified as hard, but I would definitely classify it as a medium problem because yeah, it's easier than the yesterday's one, and the yesterday problem had minimum difficulty. So yeah, okay, so let's move to the task description. We have an office buildings, and as you can see from this pretty picture, we have some employees working in it, and they request to move. They no longer want to work at their boring job, and they want to go to their new and exciting job. And yeah, we have n buildings, and we have a list of requests. Each of requests confirms that a certain person wants to move from one building to another. And we are very good people, so we want to maximize the number of requests that we can fulfill, basically, or accept. However, we are also a practical people, and we have a condition that the total number of employees in each building should remain the same after we've accepted all these requests. But as long as we are good people, we want to maximize the number of requests that we can accept, and that's the goal of our task, is to find this maximum number of requests that we can satisfy so that the condition about number of employees not being changed still holds. Okay, so let's take a look at the constraints for the problem. As I said in the previous video, it's very, very useful and it's absolutely essential. So, and here we can instantaneously see that the number of office buildings is very small and the number of requests is even smaller, which instantaneously suggests us that there must be a brute force solution to this, and that's exactly what I'm going to show you in this video. So first of all, we are going to take a look at the recursive solution, recursive brute force solution. And yeah, once again, I will refer to the yesterday's video, and I would like to emphasize this point because it's very important. For every single recursive function, we need exactly 3 things: our recursive state, the base of our recursion, and our recursive transitions. If we have these 3, we have a recursion. If we don't have these 3, we do not have a recursion. So let's define our state and our base and our transitions. And let's start from state. For the state, we are going to have a number called request number, which basically tells us that currently we are looking at the request with a certain number, and we have already processed all of the previous requests. We have either accepted them or declined them. And we also have this list, which I called employees balances, and it shows us the result of our processing of the previous requests. And basically it shows us how much employees does a certain building has gained or has lost. So for example, if we have an entry in employees balances that says that employees balances with index 2 is equal to 5, this means that second building have gained 5 employees. Okay, and our goal is that after we have processed all of these requests, we need this array to be filled with zeros, which will mean that no building has acquired any employees. So that's our goal. And basically, this was our transition to the base of our recursion. Because in the base, we check just that. If we have processed all the requests, we just check if all of the buildings have exactly the same number of employees as before, then we can safely return 0. And if not, we need to return a very, very small number because we have a maximization problem on our hands. So we must signal to our recursion that something went really, really wrong. And that's exactly what we're doing here. Okay, and the only part of this recursion that is not fulfilled just yet is recursive transition. And we have two transitions in here. We can either decline the request or accept it. So let's see what happens when we decline it. When we decline it, our result is basically equal to the recursive call with the following parameters. We move to the next request. Our employee balances doesn't change, and this request variable is just here for our convenience. It's not a part of the recursive state. Okay, so what happens if we accept a request? Then our answer consists of two parts. The first part is just a number 1, because we've accepted this request and it should count, and we should add to this value a recursive call that will take as a parameter a next request number, changed employee balances, and the same request parameter. How do we change employees' balances? Since we have accepted the request, we need to increment a number of employees in one building and decrement in the other. And that's exactly what we are doing here. After we've performed a recursive call, we need to roll these changes back. And basically, yeah, we choose the maximum between these two options. We either skip or not skip, and we return the result. And that's it for this solution. It passes all of the tests in 48 milliseconds. And okay, let's discuss what's the complexity of this solution. I have driven, so basically there is this painting, if we can call it painting, that I have drawn for you, and it shows the recursion tree in here. And at the beginning we have not performed any of our choices, and our balances list equals to 0, 0. And at each step we either choose a certain request, so basically, yeah, accept it or decline it. And we do it every single time, accept it or decline it, accept it or decline it. And our balances array changes. And this lower level corresponds to our base case in our recursion. And in each of the sleeves, we perform exactly an operations just to check if our employees' balances list only contains 0. And how many of these leaves do we have? It's easy to see that we have exactly 2 to the power of requests.length leaves. So our complexity, it's not like written here. It's actually big O of 2 to the power of requests.length. And then we need to multiply this value by n. That's our complexity. Cool. It works, it passes the tests, but can we do better? We certainly can. And the idea for this is the following. As you can see in this base scenario, in our previous solution, we went through all of these balances list. But turns out we don't have to do that. We can just enhance our state so that it contains the number of buildings that have non-zero balance. And if this value in the end is equal to 0, then we can safely return 0 as an answer. And other than that, we return integer min value. Okay, so I will leave to you how to calculate this value as an exercise, but don't worry, I will not leave you alone. I will pass the code of this solution in the comments of the video, so don't forget to like, subscribe, all the good stuff, press the bells or whatever. Okay, so the final solution that I would like to talk to you about is the non-recursive solution. And for this, we will need to introduce the concept of the bit masks. So what's a bit mask in context of this problem? So suppose that our request length is equal to 3. Then suppose we have chosen some requests for approval and we've declined some other requests. We can represent these decisions of ours by a bit mask. So for example, this bit masks tells us that we have declined the first request, we have accepted the second one, and we have declined the third. So whenever we have a bit set to 1, if the is bit is equal to 1, the bit with index I, it means that we've accepted the request with index I. And if it's equal to 0, then we've declined the corresponding request. So we can iterate through all of these masks. There are exactly 2 to the power of request.lengths of them. So because, it's quite easy to see that this number in decimal is 0, and this number in decimal is 7, and we have exactly 8 numbers between 0 and 7 inclusive. So and for each such scenario, we will check if the number of employees in all of the buildings has not changed, and if so, we will update our result with possibly new best value. And the complexity of this solution is big O of 2 to the power request.lengths time n. And it's possible even to remove this .n multiplier, but it's not really easy. So one of the solutions that I have in mind basically requires the usage of gray code. There is such thing. I will probably leave a link in the description to it. But it works and it can help us to remove this parameter from the solution. But it's not necessary in this problem. Okay guys, we finally made it. I hope that you've enjoyed this video because I really tried to make it as good and as fun for you as possible. If you have any comments or any questions, feel free to post them. I will be super happy to answer them, I swear. And so please press like, subscribe, all the good stuff. I will try to post these videos quite often, and I not promise that I will do it daily, but I will do my best. So thanks for listening, have a nice day, and have a good one. Bye.